Welcome to Fix and Jiggers. This is what we've got today. A TR-808 rhythm composer from Roland. Very famous piece of gear used in lots and lots of music. 16-step programmable drum machine. But this one's not working. So it ain't doing nothing. You turn it on and nothing happens. So we'll find out what the story is. Of course, first place is to start at the power supply and see that it's getting voltage from the wall. So let's see how we go. Here we are inside the TR-808. One of the dangers of pulling apart a piece of gear like this, there are so many exposed components in there. If you drop a screw inside and it shorts out something on the circuit, you can cause so many problems. So when you're pulling these apart, it's really good to take photos all the way along. You can see these little covers that stop dust getting into the switches, and same as the pots and sort of thing. So take a photo when you first pull it apart so you remember how it all goes back. And then it also lets you, if there's something weird there, you'll be able to look in the photos and look carefully to make sure there are no screws or washers or anything like that stuck in the circuit somewhere. So the problem with this one is that it just won't start up. The first thing I can see when I unscrewed it was this wire here is completely squashed. So it's been trapped when the thing has been screwed together. And the owner actually pulled this apart himself to adjust the cowbell sound, because there are trim pots here and you can adjust clap, or actually to adjust the clap, because he wanted a lower pitched and longer decay on the clap. So I can do that. I can set that up for him like that. But when he put it back together, it didn't work. So I think he's probably crushed a wire. So I'm just going to do a continuity test on this grey wire here to see whether it's open circuit. So let's check that wire. I've got my clip on there, and if it's connected, I should get that on the meter when I connect. So let's check the pin that it goes to, and we have 0. So that cable is okay. The next thing I'm going to check is this power plug, because it's a bit rough. There's some screws hanging out of it, so let's have a look inside and see if there's actually power getting to it for starters. So power plug was really badly tightened up. The wires were hardly making contact with the connectors, so we'll fix that. Go from there. Okay, power plug's fixed. Now on the search for power. So I'm going down here to the active lead and it's getting 245 volts. So that's correct. Then we move on to where the power is going from there. Just to stop having to battle with this, I've unplugged these plugs and I'm going to remove the other plugs down the bottom here, which go to the bottom of the board here. I'm going to remove those so that I can get access to the power supply. So now we can actually get the main board out of the way, so it's nice and safe. And now we've got access just to the power supply circuit. We can see what's going on here. So I think I found the problem already. This power cable here. So before I fix the wire, which I think is the problem, I'm going to check these capacitors in the power supply as well, because they're probably 30, 40 years old. And I've just pulled it out of circuit, one leg of it, so I can test it on my leakage checker, and this one's taking ages. So I have a feeling that that's got quite a lot of leakage. It's a 1000 microfarad 35 volt capacitor, so I might swap both of those out. Again, it's been a few minutes trying to charge this 1000 microfarad capacitor and it's still not doing anything. And when I switch it to discharge, you can see it is discharging, so it is holding some power, some charge, but it's leaking too much. I'll put it back on again. It should really charge up and go to green, so it's not doing that. So I'm going to replace both of those. I've got some new capacitors here, 1000 microfarad 35 volt. I'm going to put those in circuit. You always got to start at the power supply and make sure that's doing what it's supposed to be doing. and stable before you move on to the rest of the circuit. It can make a big difference to the tuning and everything. So it's the first place to start. So this is my good capacitor that I'm going to put in, and this is what it should look like when I put it on the leakage checker. So here's the good capacitor, bang, it charged. So that's what we wanted from the bad one. Got a couple of new capacitors in circuit, and it just reminds me of when I was doing my apprenticeship. We had, a lot of people put components in, solder them up and then cut the legs off, but we had a specialist technician who dealt with military specification gear like flight box recorders and all that sort of stuff. And he said what they do is they put the component in, trim the legs off so there's just a little bit sticking through the board, and then solder them, and that actually seals the lead for the component so you don't get corrosion through the lead. So we're talking about extreme weather conditions where they can just sort of hose them off if they need to and dry the circuit down. They don't want corrosion through the lead, and the lead obviously won't corrode. So if you have the lead solder covering the end of the wire, then it seals it basically and stops it from corroding. So anyway, you don't need to go to that much detail on a circuit like this, but it doesn't hurt. So rather than just putting the wire through the board, soldering it and then chopping off, you can actually cut it to fit and then solder over the top of it. It gives you a much more reliable contact. I went and checked the other capacitors while I was there, and this one's a 1000 microfarad 16 volt. Couldn't get that to charge at all, so I've swapped it with a new one. This one was a 470 microfarad, same thing, can't get that to charge either. So you can see I've actually got them on the checker here and they're still not charged after about 10 minutes. So obviously leaking pretty badly and time to change them. So luckily they're cheap. Swap those out so the power supply is nice and stable. There's three more little capacitors down here. They're 10 microfarad 16 volt. I've pulled one out just to check it. So I'll put it on the meter. And that appears okay. So I really don't need to go through and replace those, but seeing as I've got three new capacitors here, I'm just going to do that. To stop screws coming undone, we used to use shellac, which was actually beetle's wings mixed with methylated spirits. So you could say, cut me some shellac. Terrible joke. I'm just going to use some nail polish. Just stick some of this on. Also, it's a good way of checking if it's been undone when you come back to it again. So you can see if it's been fiddled around with. So a couple drops are there on there. So there are all the bits I've replaced. Probably for, I don't know, $5 or so worth of bits. So hunting around a little bit more, I found where the cable should go. So the white cable there should go into that connector. It's obviously been broken off. When you're soldering contacts like this that have a hole through them, don't be slack and just solder it onto the tag. Actually pull out the old wire, make sure the hole's clear, put your wire through, fold it over and solder it so that it can't come undone, because almost guaranteed you'll have to open it up again at some stage and fix it, which is a real pain. Just come to give this a zap with some circuit cleaner. While the air compressor was on, I went and blew the whole case out as well to make sure there were no leftover bits. Dust, but also the leads from any components that I've cut off or have been cut off before. Just gave it a really good clean out. Cleaned all the connectors with some circuit cleaner, and it's looking really nice. Here's my super clean circuit. All these knobs have been sprayed out a couple of times, and now they're beautifully smooth. Before these would hardly turn, but now they're beautifully smooth, same as all these ones. A couple of the caps have come off, which I've still got here. which I'm going to glue back in there, but that's fine. I'll clean it all up, clean up all those bits when I'm done. All the dust covers have to go back on the switches, but it's just much easier when it's clean. You can really makes it much easier to fault find. I think detail on an old piece of gear like this is important, so I've got a new cable tie which will tie this back like is supposed to be done so it doesn't get tangled up when you put it back together. Just a small thing, but makes it more reliable, and it's how it was designed. Okay, it's all tied back nice and neat. I've checked all of the solder joints on all of the connectors to make sure they're good on the other side, and now we can start plugging it all in, putting it back together and fire it up. So before we put it all back together, I'm just going to check that we've got power. So I've got it plugged into the wall, I've got 240 coming in, I've already tested that, and then here on these connections I should be getting minus 15 volts, and on here I should be getting plus 15 volts. And then we move over to this part of the circuit here. On these lower connectors, I should be getting 5 volts on the orange and also 5 volts or so on the yellow. So that's fine. This other connector here is for the battery compartment. So this will actually run off 9-volt battery as well. So there we go, we've got power. So that's good. So now we've checked the power and that's all good. We'll connect it all up, fire it up, and get it going. Okay, let's fire this up and see what happens. Oh, got lights. That's nice. And I'm in manual mode, so I should be able to just play one of the preset patterns. Yep, cool. That's working, but the switch is a bit dodgy, so I'll have to get in there and check that. Might need to clean that out a bit better. But yeah, she's working. Fixed.